Bismillahirrahmanirrahim. My name is Malaika and I'm from Department of BS Chemistry. My topic of today's presentation is alcohols. Aliphatic organic compounds containing hydroxyl group as functional group are called alcohols. Alcohol containing one hydroxyl group are called monohydric alcohols, and those containing two or more hydroxyl groups are known as polyhydric. As you can see in the given equations below, that in the first example, with carbon chain only one hydroxyl group is attached, so these types of alcohols are called monohydric, and in the second you can see that there are two hydroxyl groups attached, so these are called polyhydric. Coming towards the classification of monohydric alcohols, so monohydric alcohols are classified into the following three families. Number one, primary alcohol. Alcohols in which hydroxyl group is attached to primary carbon is called primary alcohol. Primary carbon is basically the carbon which is further attached to one carbon or no more carbon. Here you can see the example of the primary alcohol. Then coming towards secondary alcohol, alcohol in which hydroxyl group is attached to secondary carbon is called secondary alcohol. For example, the example is given in which the secondary carbon is attached to two for more carbons. So these types of carbons are called secondary carbons. And in tertiary alcohol, alcohol in which hydroxyl group is attached to tertiary carbon is called tertiary alcohol. Tertiary carbon is the one which is further attached to three more carbons, as you can see in the example. Now coming towards the preparation methods of alcohols, so first of which is hydration of alkenes. Basically it is the addition of water to alkene. The main reaction is given. Now coming towards its mechanism. You can see that first alkenes first the formation of carbocation occurs, and then the nucleophile attacks on the carbocation to form the respective product alcohol. Second one is hydrolysis of alkyl halides. So the main chain reaction is given and its mechanism is also very simple. Here first again the formation of carbocation occurs, and the second step, halide ion reacts on the carbocation. Third reaction for the preparation of alcohols is reaction of Grignard reagent with aldehydes and ketones. Here you can see that first I have written the example of formaldehyde or methanol, which is an aldehyde. It reacts with Grignard reagent. In this reaction, the carbon of the formaldehyde is acting as a carbocation, and the methyl group of the Grignard reagent is acting as a nucleophile. It is reacting on the carbocation to form the respective product, and this product then again reacts with water molecule to form primary alcohol and side product. In the second reaction, I have taken ethanol, which is reacting with Grignard reagent. Again, the carbocation of the ethanol is being attacked by the nucleophile of the Grignard reagent, which is methyl group, and the respective product is formed. Then this product reacts with water molecule to form secondary alcohol and side product. In the third reaction, I have given example of ketone, which is propanone. Here again, the carbon of propanone is acting as a carbocation, and the nucleophile, which is the methyl group of the Grignard reagent, it is attacking the carbocation to form respective product, and then this product further reacts with water molecule to form tertiary alcohol. Fourth reaction for the preparation of alcohols is reduction of aldehydes and ketones. In these types of reactions, basically aldehydes and ketones react with lithium aluminum tetrahydride, which is a reducing agent, in the presence of nickel or platinum, and only two molecules of hydrogen are being added to aldehydes and ketones to form alcohols. Fifth method by which alcohols can be prepared is reaction of Grignard reagent with esters. Main chain reaction is given. Coming towards its mechanism. Now in first step, esters react with Grignard reagent. Here the carbon of the ester is acting as a carbocation, and it is being attacked by the nucleophile, which is the methyl group of Grignard reagent. The respective product is formed. Then this product is further hydrolyzed to form ketone and a side product. Then the third step, again the ketone is attacked by the Grignard reagent, and then the product form react with water to form alcohol and side products. This was all about the preparation methods of alcohols. Now coming towards the reactions of alcohols. First reaction of alcohol is with hydrogen halide to give alkyl halide. The main chain reaction is given. Now as you can see in the mechanism that first the hydrogen bromide bond is broken and alkyl oxonium ion is formed. Alkyl oxonium ion is basically the ion in which oxygen has a trivalent valency. Then in the second step, the alkyl oxonium ion bond is broken and the nucleophile attacks on the alkyl group to form alkyl halide. The second reaction is reaction of alcohol with thionyl chloride, phosphorus trihalide to give alkyl halide. These two reactions also occur with the same mechanism. Third reaction is acid catalyzed dehydration. In this reaction, alcohol condenses to give an ether. Now the first step is basically an acid-base reaction. In this step, protonation of the alcoholic oxygen to make a better leaving group. This step is very fast and reversible, and you can see that the lone pairs on the oxygen make it a Lewis base. Now in the second step, the oxygen of the second molecule functions as a nucleophile and attacks to displace the good leaving group, which is a neutral water molecule, by cleaving the carbon-oxygen bond. And this creates an oxonium ion intermediate. In the third step is also an acid-base reaction, and here the proton is removed by a suitable base to give an ether product. Fourth reaction is preparation of esters. There are three types of methods by which alcohols produce esters. First is alcohols react with organic as well as inorganic acids to form their respective esters, as you can see in the example given below. Second is glycerine reacts with a mixture of concentrated HNO3 and H2SO4 to give an ester called glyceryl trinitrate. As you can see that here glycerine is reacting with 3 molecules of HNO3 in the presence of H2SO4 to form nitroglycerine and side product. Third reaction is esters are also formed by treating acid chlorides with sodium alkoxides, as you can see in the example. Fifth one is oxidation. Coming towards primary oxidation, so a primary alcohol is first oxidized to an aldehyde, which is further oxidized to a carboxylic acid in the presence of potassium dichromate, sulfuric acid at 50 degrees C. Coming towards oxidation of secondary alcohol, so a secondary alcohol is oxidized under similar conditions to give a ketone which is not further oxidized in the same conditions. And tertiary alcohol, so tertiary alcohol is first dehydrated to an alkene in the presence of an acid. Then alkene is oxidized to a ketone and a carboxylic acid in the same conditions. Sixth one is cleavage of 1,2 diols. So 1,2 or vicinal diols are cleaved by periodic acid hydrogen iodide tetraoxide into 2 carbonyl compounds, as you can see. Coming towards the physical properties of alcohols, so alcohols are butanol are generally colorless liquids with characteristic sweet smell and burning taste. They are readily soluble in water. The solubility of alcohols is due to hydrogen bonding, which is significant in lower alcohols but decreases in higher alcohol. Melting and boiling points of alcohols are higher than corresponding alkanes. Coming towards applications of alcohols, so alcohols are among the most common organic compounds. They are used as sweeteners and in making perfumes, are valuable intermediates in the synthesis of other compounds, and are among the most abundantly produced organic chemicals in industry. Perhaps the two best known alcohols are ethanol and methanol. Ethanol is used in toiletries, pharmaceuticals, and fuels, and it is used to sterilize hospital instruments. It is moreover the alcohol in alcoholic beverages. The anesthetic ether is also made from ethanol. Methanol is used as a solvent as a raw material for the manufacture of formaldehyde and special resins in special fuels, in antifreeze, and for chelating matters. That's all about alcohols. Thank you.